Hey guys, sorry you couldn't be here today, but you've got your 7-1 notes coming at you going over 0 and negative exponents. One thing that might help you with this is also watching the vocab video that I put in Google Classroom, so make sure you catch yourself up on that as well. So first thing that we want to do is example 1, obviously, but remember that anytime I have a negative exponent, it becomes positive in the opposite location. So if I have a fraction, and the exponent is negative in the numerator, it becomes positive in the denominator. So that's exactly what we have going on in the case of example 1a. I've got this -3 in the numerator because we know that we can put any fraction over 1. So in order to simplify this, the first thing I need to do is get positive exponents. So I'm just going to flip this over. I'm basically taking the reciprocal of it. So this is going to turn into 1 over 4 to the third power. So you can leave it like this because you have a positive exponent. Some of your problems, though, are going to ask you to actually simplify this down so that there aren't any exponents there, especially if your base is a number. So when I do 4 to the third power, or 4 times 4 times 4, I get 1 over 64. And that's all you're going to do for part A. Part B reinforces the rule or your definition that I gave you in your vocab that anything raised to the 0 power has a value of 1. And since I'm only raising one thing to the 0 power, my whole answer is 1. There is going to be a couple where only one piece of your problem turns into 1, not the whole thing, but we'll get into that later. Part C brings us right back to where we were with example 1. And we have a negative exponent, so if it helps, throw that over 1, because now it's really easy to take the reciprocal, and you're going to write it as 1 over 3 now squared. And again, to simplify this, we want to write it as 1 over 9. Okay, so first goal in all of these is to make all of our exponents positive, and then to simplify where we can. So there's a couple things about part D that I want to talk about. So the first one that we clearly need to talk about is this -2. Okay, well, we know to make that -2 a positive, we've got to flip the location. The other thing I want to talk about are the parentheses around -4. What this does is it groups that negative with that 4. So when I flip this upside down, I'm going to keep those parentheses with the -4 and put the +2 on the outside. So now what this does is it forces us to square -4. So we have to take -4 times -4, and hopefully at this point we know a negative times a negative gets me a positive, and in this case it's going to be a positive 16. However, you are going to run into cases where that negative is not grouped with the number. So if I, for instance, tell you to square -3, the only thing that squared is on is the 3. The negative does not get squared with it. That negative isn't grouped with the 3. So your answer here would be -9. So if you have parentheses around a negative number, you're going to apply your negative times a negative rule. If you don't have parentheses around that negative number, you are just tacking that negative onto your answer. A little bit different to get used to. It's just one of those weird things with exponents. So we're going to take what we did in number 1 and apply it to what we did in number 2. And the only thing different here in number 2 is once I make my exponents positive, I can't simplify anything because you'll notice I have variables, okay? And I don't know what they are. So in part A, it's exactly like what you guys did in part A in number 1. Throw a 1 under that x to the -9. If that helps, then flip it upside down because the -9 now is clearly negative in the numerator. To become positive, it moves to the denominator. And all I have is 1 over x to the 9th. Part B doesn't get trickier. You just have to pay attention to detail a little bit more because technically this 4 has an exponent of a +1 and that B does as well. So it's not this entire thing that has a negative exponent that you have to take care of. It's only that c to the -3rd that's going to change. So flip this or put this over 1. Now I like to go from left to right and decide if my term is going to stay or if it's going to go based on if my exponent's positive or negative. So I have 4 to the first. That 1 is positive, so that 4 is going to stay in the numerator. The c to the -3rd clearly negative, so we've got to flip it downstairs to the denominator. And then the b gets raised to the positive first. So because that 1 is positive, that b stays up in the numerator with the 4. And now this is your answer. Okay, all of my exponents are positive. I can't simplify anything else, so you're done. Now, some of you might be looking at part C going, did she make a typo? No, I didn't. This is simplified. There's no negative exponents, and you're going to get some problems like this, and all you're going to do is tell me that they're simplified already. Okay. However, if I threw the problem at you like this, 2 over a to the negative third, now here's where we've got to think opposite, right? So my exponent now is negative in the denominator. So to make it positive, I've got to bring it up with that 2a, or with the 2. So now this answer becomes 2a to the third because I'm left with technically a 1 in the denominator, which we know doesn't get written. All right, so there's an example of when you have a negative in the denominator, you got to bring it up top. All right, so part D is the last one for this example. So take a look at your two terms here. You have n to the negative fifth up top and m squared in the bottom. We're realizing that n to the negative fifth is the only negative exponent here. Since this one's already written as a fraction, all I'm going to do is I'm going to take that negative 5 and I'm going to put it in the denominator with the m squared. Since that squared is positive, it stays exactly where it's at. It's like having a positive attitude, we want to keep it. If our attitude's negative, we want to change it, which is why the n gets flipped to the bottom. Okay, well now we're left with what appears to be nothing in the numerator, but we always know that we can put a 1 in the numerator because technically the n had a coefficient of 1 on it. And that's it for part D. All right, so moving on to example number 3 here. Very similar to what we did in number 2, but then there's an added part to it because if you'll notice in the directions, we now are told what our value of our variables are. N is negative 2 and W is 5. So the first thing that you're always going to want to do on these, just to make life easier, is to simplify all of your exponents, make them positive, get rid of things raised to the 0 power, etc., and then plug things in. So in part A, we'll notice that we have two parts here. So I have n to the negative fourth. So right now, that's in my numerator. So I need to put n to the negative fourth in my denominator, which makes it positive. And then this w to the 0, we know anything raised to the 0 power is going to get us 1. And that's the only thing that turns into 1. Notice how I didn't change my n to the negative fourth to 1 because it wasn't raised to the 0 power. So in the numerator, all I'm left with is 1. All right, so that was the application of both of our vocab words today. But now we need to do something that you guys know how to do, and we need to now plug in negative 2 for n and evaluate. So because that n is negative 2, we're going to group that negative with that 4. So we've got to take negative 2 to the 4th power. So negative 2 times negative 2 times negative 2 times negative 2 gets us 1 over positive 32 because I multiplied an even amount of negatives. So moving on to part B here, looks very similar to what we ended example 2 with, where we had a negative exponent in the numerator and the denominator exponent was okay. So that tells us that I'm going to have a 1 in my numerator because this n to the negative 1 is going to move downstairs right with that w squared. So I've got a w squared n in the denominator, 1 in the numerator. So now we need to plug in a 5 for w. So my work is now 1 over 5 squared. And then I need to multiply that because remember when I have a variable written right next to a variable, they're being multiplied. So 5 squared times negative 2. Okay, and I put that in parentheses because I don't want it to look like a subtraction problem when indeed it is an actual multiplication problem. So we need to follow your order of ops. So 5 squared gives us 25. At this point, we can't do anything with a negative 2 because it's technically to the first power, and I know negative 2 to the first power is just going to be itself. And then in the denominator, I've got negative 2 times 25 to get us a value of negative 50. And that's it. That's what we have to do on part B. So it looks like a lot of steps just because I did one at a time, but they were all very simple steps. So moving on to part C, take your numerator, n to the 0. Anything raised to the 0 power is going to give us 1. So I know right now in my numerator I have a 1, and I look at that w to the 6. Do I have to change anything? Think to yourself, is the exponent positive? It is, so it's going to stay where it's at. All right, so now we're going to plug stuff in. Now we're going to leave that 1 in the numerator. We're going to plug a 5 into your denominator. We're going to raise that 5 to the 6th power. It is a very large number. We have 1 over 15,625. And that's your final answer. Okay, so in part D, very similar to the added example I gave you in part C in number 2, because now my negative exponent is in my denominator. So remember, in order to make that positive, I've got to flip just that variable up to the numerator, which means my w, technically to the first, ends up in the top, so you can see that it became positive. Because w is the only thing that had that negative 1 on it, the n stays in the denominator. Now, since everything is raised to the first power, and we know that when I raise something to the first power, I just get that number back. 5 to the first gives me 5, because w is 5, and to the first is negative 2. So we didn't have to do anything after we plugged in. All right, so that's how you evaluate expressions when you have exponents. Remember, get all of my exponents positive, get rid of the zeros, and then plug stuff in. Trust me, it makes life easier. All right, then the last problem that we have going on is a population of insects that triples every week. I've given you the equation that the number of insects is equal to 54,000 times 3 to the w. W is the number of weeks. And you'll notice that I give you 3 different values of w. W for negative 2 basically means 2 weeks before my study started, 0, and then 1. So then we want to find out basically how many insects we have at that point in my experiment. So you're going to do this just like we did in our last example. So if w equals negative 2, plug that in for the expression that I gave you. So 5,400 times 3 to the negative 2 power. And again, you want to take care of your negative exponents. So you're going to flip this 3 to the negative 2nd in the denominator. 5,400 gets left on top. So now your problem is 5,400 divided by 3 squared. Well, we can simplify that 3 squared to 5,400 over 9. Don't reach for your calculator. Think about what 5,400 divided by, or 54 divided by 9 is. Hopefully you came up with 6. You have 2 zeros behind the 54, which means you're going to have 2 zeros behind the 6. And then this would be 600 insects that are left. Okay, so 2 weeks before the study started, I had 600 insects, which makes sense because if we're tripling every week, it means it's getting bigger when we're going on in the study. But if I'm going backwards in my study, it means that I didn't have that many insects. So what we want to do next is figure out how many insects I started, or that I had when the study started, because after 0 weeks is basically ground zero, right? So w equals 0. This is just an application of your anything raised to the 0 power is 1. So 3 to the 0 is 1. So I'm just multiplying 5,400 by 1 here, which tells us that when I started the study, I had 5,400 insects. And then your last problem that you've got to do here, not that pen, that's harder to read, is when w is equal to 1. So after 1 week of doing this study, how many insects do we have? So again, plug in that 1 for your exponent. 3 to the first power, hopefully by now we know is 3. And then when you do 5,400 times 3, you get 16,200 insects after the first week of your study. All right, so just a very basic application problem of using your exponent properties when you have negative exponents, when you have 0, and when you have an exponent of 1. So your homework's posted on Math Excel. You do need a work page, and I will see you next time. See you guys.